Yeah, good evening, sir.
Good evening, Murali.
Yes.
So Murali, before others joins, right? So I also enrolled for solution architect under you only. I think sometime in the next
Oh,
month, which you are starting, right?
yes, yes.
I'm just thinking whether to go for that one now or to take up something in the Python side of it. I'm just thinking. I don't know what is what, but just thinking because this
Mhm.
one also I have to complete, and
Mm.
later on. But what do you suggest? Like now, anyways, I am like going through this. Should
Mhm.
I take the solution architect immediately now?
No, that's also first you practice all these things and you get a certificate. Then
Ah, yeah,
you get interested. Otherwise, you will keep on learning. Nowhere you might have implemented, and you will have more fear only.
yeah, that's
Because
true. That is true. Right.
yes,
That.
so we achieve something, then you will not have fear. No, this is only not. I already learned this for the exam. I know
Correct.
this.
Correct.
This confidence will be more, and so that you will understand the solution architect is whatever we learn now, that will go in depth.
In
That is
depth.
for example, whatever yes, S3 bucket I might have told you, like let us say 5 slides. Now in
Hmm.
S3 bucket they will go for 10 slides.
Ah,
two
okay.
more two more points, that's it. But that material which I think I already shared you with all the services, correct na?
Mm-hmm. Hmm.
If you go through that services itself, it is already there with more pointers which you should know.
Okay.
I think where is that certification paths? I think I didn't send you. I think I separately mailed you guys. Getting your email ID?
No,
No,
I haven't received at least.
no. 1 minute. I'll just check it. On that day, I think I get your all your email IDs. No. Okay. How to achieve 100% voucher? I have mailed you. Mhm.
When did you mail that?
How to achieve 100%? I have mailed on 18th September.
18 September. Let me check.
Sorry. 29 September. 29 September.
29 September. '28. Yeah, that is there.
So I will just send one more mail for this full services learning material so that you'll be able to prepare for the exam. AWS services. So not I'm just sharing it. Okay, I've attached it. It's taking some time to load. Let it get load. I'll just send you the mail. Okay, and I'll inform you. Yes, you guys, you're able to see everyone. Hello.
Oh, sorry, I was talking mute. Yes, I am able to.
Okay, fine. Fine. So we go for the last module. That is module number 10, auto scaling and monitoring. As the name itself says, what is this one? Scaling means what?
Measuring,
No,
or maybe I think
increasing here in the cloud.
increase. Yeah,
Yeah,
like
increase or
expanding or
decrease, like your rubber band.
yeah.
Expanding, yes, expanding or decreasing. So scaling. Now, how it should happen? Automatically. How it should happen? Automatically. How it will automatically happen? Because we are monitoring. We keep on monitoring is we give a condition. We give a condition. If this condition met, you increase the scaling. Okay, let us see. What are the things we are going to discuss? We are going to discuss about load balancer, CloudWatch, and EC2 Autoscaling. After this completing this module, we should be able to know about how to distribute traffic across Amazon Elastic Compute Cloud and identify how Amazon CloudWatch enables you to monitor and what is EC2 Autoscaling. First one, load balancing. As the name itself says, what is it's going to do?
It will make sure that as and when there is increase or decrease need to be done, it will balance the requirement.
Yes, balance the load. Balance the load. And elastic
No.
means, as we already mentioned, scaling. It can able to do it by itself. So there are a lot of workloads are coming. Let us take this is Amazon website, Amazon.com. More number of people are coming. We have only two servers and two servers here on the other side. One availability zone and other availability zone. So this load balancer will distribute the traffic. Let us see. First one, you see, multiple users are coming. Now this load balancer first will distribute the traffic among the targets. We call this as target group. What are this target group means? TG. That is, we can have the target group can be, that is what the user has to be redirected. It has to be redirected either to EC2 instance or containers or IP address. IP address is physical server or a lambda function. Which one where I want to distribute the traffic? That will be decided by the load balancer. Now let us take this is only 20%, this is 30%, this is 30%, and this is 20%. Now next workload is coming. What load balancer will do? Load balancer will distribute the traffic where there is okay. First, the user is asking some questions, and first Elastic load balancer will check who can able to answer this question, either EC2 or container or IP address or lambda. Fine. If only these two people are able to answer, then load balancer will check whether who is having low workload. Now when we see that 20 is here and 30 is here, so now where this load balancer will send the traffic, that question to container or EC2.
Mostly at
Its
EC2.
main job is balance. Yes, exactly. It is balancing the workload. Correct? Now it is balancing the workload. So first it will go and send it to EC2 instance. Then if both are equal, then it might to come to containers. Now, in case if this EC2 don't know the answer, then what we will EC2 will do? I mean, what load balancer will do? Will send the traffic to the containers only. So it's not like only considering who can answer. I mean, based on only the workload, who is having less workload, but also who can able to answer what is the question answered by the user. Is it answerable by which one? Which can able to provide the solution? That is also a matter. Now, this distributed incoming application or network traffic across multiple targets. These are called targets, multiple targets in a single availability zone, or it can be in multiple availability zones also. So, what is the main thing is load balancer will manage both, whether you are in a single target value or multiple targets, or in single availability zone or multiple availability zone. Wherever you are, load balancer will properly distribute the traffic to the users. Now this load balancer is one of the service, main service, okay, which we will be able to distribute the traffic. Now this is divided into three types. That is, first one is application load balancer. Mainly we'll be using it for all the websites, that is HTTP and HTTPS traffic. And we'll be using it for microservices like containers, that is small container service and microservices also we'll be using. Mostly we'll be using the for all developing application and website. We'll go for HTTP and HTTP request and all. We'll go for ALB, that is application load balancer. Now this will operate on the operation OSI model number 7th layer, that is application layer. Next type is network load balancer. As the name itself says, network. It will load for TCP UDP. TCP means transfer control protocol, universal data protocol. That means you can able to transfer more number of data. Your application or website or something, it's going to be taking more workload. Then you go for network load balancer, where you can able to route the traffic to the targets based on IP data, and this one alone can able to handle millions of requests per second, while maintaining ultra low latency. While maintaining ultra low latency. Latency means what? Reduce delay. Correct, na? So it will reduce the delay. It will definitely make sure that it is reaching your application faster and operates at the transport layer. Now third one is classic load balancer. Now, classic load balancer is the old one. Before they invent network and ALB separately, first they used only classic, which was taking care of both. You see, HTTP and HTTPS access like your application, and TCP, SSL, all these from the network also it will handle. But the only drawback is it will handle load balancer across multiple EC2 instance only, not with the target groups. It can manage to trend the traffic only to EC2 as it's a previous generation. So it operates at both level, application and transport layer, but it will be slow when compared to these two. Now, as I told you, like normally all applications will be using ALB because that is enough for your website or app. But where we need this network load balancer, where we need millions of requests are happening every time, and sudden volatile traffic pattern you're able to see. So best example would be what I think your Instagram. We can say millions of people are using every second, correct? So that will become network load balancer where the load has to be proper. You are able to watch the videos, photos, everything within a second. Other applications we can able to go for application load balancer, but mostly we'll be using application load balancer. Okay, you're getting this. Yes. Now this load balancer, as I told you, load balancer is the main thing. This will accept the incoming traffic and it will send to the traffic. Now for this load balancer, one more key thing is that is called your listener. That is like a PA. What this listener will do, listener will checks for the connection request. That means load balancer is going to send the work to traffic to the target. That is your target. It can be EC2, it can be just now Isana, it can be IP address, it can be EC2, it can be Lambda, it can be a container also. But listener, what it will do, it will go and check whether the target is first healthy or not. If it is healthy, it will pass the information to load balancer and load balancer will send the traffic to him. Now, in case if it found no, the target is not healthy, it will route the traffic to the other one. It will route the traffic to the other place. If you have already launched in Amazon availability zone 2, if you are already started with Amazon availability zone 1 and it started in 2. So with application load balancer and networking load balancer, we can able to register the targets in our target groups and route the traffic to the target groups. So with classic load balancer, you register the instances with the load balancer. As we mentioned, classic load balancer will do only with the EC2 instance. So first we have to register these targets. So target groups means what? What are target groups? Could you please say the target groups? Just now I told you what are the target groups. These four are
Yes.
the target groups: EC2, containers, IP address, and Lambda functions. So all these things are the target groups. Now, these target groups, first we have to, when you are launching, when you are adding, first it has to go and register in the load balancer. Then load balancer will check whether it is in good health condition or not. If not, it will not send the incoming traffic to that particular resource, particular target. If it is working fine and it's healthy, then it will send that traffic to the target. Okay. Now, why we need load balancer? Mainly, load balancer is for highly available and fault tolerance applications. Fault tolerance means we don't want to do anything. Whenever there is some issue, it will resolve by itself. Next, it can able to use in containerized application as well, and it has the main elasticity and scalability. It will keep on adding the resources, servers, and removing the servers also if it is not in work in if the server is not necessary or there is not that much workload. You can able to have a VPC connection with the VPC will be connected through your elastic load balancer. We can able to connect. Then hybrid environment, we can able to have both. That is, elastic load balancer can be common and it can able to send the traffic to cloud also and on premises also. It will support then invoke lambda functions over HTTPS also. We can able to invoke lambda functions over HTTPS from the load balancer. We can invoke because as lambda is one of the target group. So these are the benefits or use cases. Now you have to say which load balancer we have to use when the situation based on the situations. As just now we learned the previous one, the types of load balancers. So you have to say whether it is ALB or NLB, network load balancer, or CLB, classic load balancer. Which one is this? You must support traffic to a containerized application. Which load balancer will support containerized applications?
Is it VPC?
No. So ALB, NLB, CLB. So ALB will work for HTTP and HTTP request, microservices and containers. I draw and showed you. Route traffic target based, mainly work for TCP extreme workload, high workload and millions of requests per second and all, it's network. And both will work, but only work with EC2 instance and somewhat slow. That is your classic load balancer. You got it? Now shall we go there? Yes. What are the types of load balancer? ALB, NLB, and CLB. So which one will do what? When we have to use ALB, when we have to use NLB, when we have to use CLB. Now you identify which one will support the traffic to a containerized application. ALB, NLB, or CLB? Which one?
Is it the CLB?
No. Again, I'll give you 1 minute time. Just to please take a look at this and please make notes. Then you will understand which load balancer we have to use on which situation.
The first one is CLB, containerized load balancer.
Hmm?
CLB.
You read all the pointers. Shall we go to that one? Yes, sir.
Yeah.
Okay. Now you tell me which load balancer will support traffic to a containerized application. ALB and NLB or CLB?
Uh,
CLB.
Murli, Murli, I think you are
Ah,
sharing that screen, right? ELB, NLB. I think it was
hmm.
some network lag was there for some time, and we didn't
Hmm.
gone through again. Like you shared it again, but it appeared only for a fraction of second. So we'll just go
You
through
want
it.
me to go back?
Yes, yes, yes. We will go through it and we will confirm.
Is it done? We'll go. Yes.
Um, yeah.
Okay. Which one will support traffic to a containerized application? ALB, NLB, or
ELB,
CLB?
ELB.
Okay. Which one you have extremely spike and unpredictable TCP traffic? Which load balancer we have to use? ALB, NLB, or CLB?
Unpredictable traffic.
Heavy traffic, heavy workload.
NLB.
Okay. Others? Okay. Next one. You need a simple load balancer with
Classic.
multiple protocols. What?
Classic. CLB.
Classic. Because it's simple.
Yeah.
Next one. You need to support a static elastic IP address or an IP target outside a VPC. Outside a VPC. You have to take everything support. That is more workload.
NLB.
ALB, NLB, or CLB. Yes, Balakson, you said something.
NLB. I said NLB.
Yeah.
NLB. Okay.
Yes.
Next one. You need a load balancer that can handle millions of requests per second while maintaining
Again
low
NLB.
latency. Okay. Next, you support HTTP requests.
CLB.
CLB.
Uh,
CLB.
I think it's CLB.
HTTPS ALB. Sorry, A.
ALP.
ALB. Okay, let me see. So first one, containers application is ALB. Second one, spike unpredictable traffic is network load balancer. You need simple load balancer with multiple protocols, classic load balancer. You need to support a static elastic IP address or an IP rate on it, network load balancer, and millions of requests per second while maintaining low latency network load balancer, and HTTPS requests as application load balancer. Fine. So load balancing will be keep on monitoring. As I told, load balancing is monitoring through CloudWatch metrics. What is metrics? That means metrics means that we set. So it is mainly used. The CloudWatch metrics is mainly used to verify whether the system performance is as expected and creates an alarm to initiate an action if a metric goes outside an acceptable range. Whether it'll keep on monitoring, like your watch having alarms, right? I think watch means your alarm clock or something. Yes, your phone also we have alarm clocks. Correct. What it will happen? No, 3 o'clock we are setting an alarm means 3 o'clock exactly it will work. Now, how 3 o'clock it is exactly taking a ring? Because this timer is running, it is keep on monitoring. We'll keep on monitoring. Same thing. We give a condition, and the CloudWatch is already set that at this time, if the situation comes, you send an alarm or a notification. So that's what your CloudWatch will go in depth in the next slides, in the upcoming slides. So now again access logs. So how can you go and check your access log? That is who came and what we have done and everything. So it will capture a detailed information about the request sent to your load balancer. Request means what are the incoming traffic. That traffic are called requests. Next, where can you find these logs? We can able to find these logs like as we already mentioned CloudTrail. So CloudTrail will capture all the details like who, what, when, and where of IP interactions in the AWS service will happen. So all these things will be recorded in the CloudTrail. So this we have already seen. Going to the end of this load balancer. Elastic load balancer is mainly for distributing incoming application or network traffic across multiple targets. As we already mentioned, what is meant by target, and one or more availability zones as well. Elastic load balancer will support three types of load balancer. One is application, another one is network, another one is classics load balancer. Next, ELB offers instant health checkups, security, and monitoring as well. So ELB, that is your load balancer, also will keep on checking, as I showed you. It'll keep on checking whether the health condition is good or not. Next one is CloudWatch. As the name itself says, what is that? This service will keep on watch the cloud. That is cloud resources will keep on watching. Now CloudWatch, we already mentioned. CloudWatch is an efficient tool which will help you to monitor things. Now, for example, to use AWS efficiently, you need insight of your AWS resource. Insight, correct? Na? We need to have some insight what is happening and all those things. Now, how do you know when you should launch a more EC2 instance? When I should launch one more instance? Is your application performance or availability being affected by a lack of sufficient capacity? Is it so? How much of your infrastructure is actually being used? All these things we can able to track by monitoring. By monitoring means we don't want to monitor. Already there is a tool called CloudWatch. It will keep on monitoring and keep the reports there. It will keep on giving you performance, like how you have your task manager. In your task manager, you are able to see this one more new tab called performance tab in your computer. Yes, in Windows 11, you are able to see task manager. By clicking the task manager, you are able to see performance. Can you click that and say what is happening there? What you're able to see there?
Kind of like at every time the value will change.
Yes, the value is changing. You're able to see how much CPU is running, memory, disk space,
Disk and network,
Wi-Fi, GPU, everything. You're able to see that.
right?
Yes, exactly. Same thing. Is anyone saying this to do it? No, right? It is automatically happening, capturing everything, right? Now, same thing, CloudWatch will be
Yes.
capturing all these details, but for all the resources it will do. So now there you can able to see CloudWatch can be used mainly for monitoring, collects the tracks and standard metrics, setting alarms. This means sending an email notification to you when some condition met. It can able to help you to perform auto scaling or auto easy to actions and events. That means if you want to send a trigger a message or something also you can able to do. But for that we have to refine the rules to match the changes in the AWS environment and route these events to one or more target functions or streams for processing as well. So now here you can able to see monitor means it help you to monitor, like you just now you saw about the task manager. It will monitor everything AWS resources and what are all the applications that run on AWS. As you see task manager, you are able to see the first one is your processes. What are all processing? Correct. Now process also you are able to see now how much CPU it is taking, how much percentage of memory it is taking, everything it is showing. Same thing. Next to collect and tracks standard metrics we can set, and any metrics also we can able to set so that it will not deviate from that. Next alarms, as I told, like we can able to send an alarm says as SNS. It means simple notification service, that is mail service is called SNS. And again whenever we perform some EC2 auto scaling or EC2 actions, at that time also at that time also CloudWatch will support. And events, as I told you, like if you have to set some event 6 o'clock you have to send a mail automatically, or if someone says do something, I want to react in this way, I want to say some, so let us say form, I have to submit it. Now how the forms when you submit it's coming thank you. Same thing, if you want to set some event, if something happen, I can set that. With the help of this we can able to configure all these things in the CloudWatch. So now CloudWatch has three types. That is, how can we set alarms? We can able to set the alarms with three methods. One is static method, another one is anomaly detection, and third one is metric method. Static means what? We give any threshold value we are giving directly. For example, here you see this is your static threshold. That means we are mentioning a condition that there are two CPUs running. There are two CPUs running. Okay. Now, if the average workload of these two servers goes more than 60 percentage for 5 minutes, that means these two, server 1 and server 2, keep on running, and their average workload is more than 60%, that too continuously for 5 minutes, then I'm giving an alarm that I have to add one more resource to it. So this condition we are setting here, as you can able to see, static threshold is static, and whenever the CPU utilization is greater than, you're able to see greater than 60% or greater than 100 we have mentioned. Now you think that 60 percentage more than 5 minutes. What is the period? 5 minutes. Why average? Because I have two servers, so I'm mentioning average, because I already told it yesterday, the security guy, why you have two securities, same thing. You always run minimum two servers. Now two servers is running continuously, so more than 60%, if the workload is there continuously for 5 minutes, please add one more server. Now the load will get splitted into 30, 30, 30. If more workload comes more than 60%, or 20, 20, 20, it will split. Now your instance will not get repaired, as well as it is not done by you, it is automatically, you have given a condition that you can able to set this in the CloudWatch. So after that, you can able to see additional condition. You can give any additional conditions you want to have, like 5 minutes or 4 minutes or 3 minutes, like that you can mention, or any condition only you have to send a mail or message. Like in the actions, you can mention if you want to send an SNS, that I'm adding one more instance. That is, see, you as the owner, you should know na, whether one more server has been added or not. For that, CloudWatch will send an alarm notification to you, like through SNS, simple notification service, that one more server is added. It will not ask you permission and all. As AWS, we don't want to ask permission. We want you to auto scale by itself. So it will not ask permission, but it will check whether it will send a notification to us. And these are the specifications which we are mentioning. That is the same thing: static threshold value, metric, what metric we are setting, namespace is the name of this setup, and period 5 minutes, and conditions we are mentioning what condition is the CPU greater than 50% or 60%. If any additional configuration is needed, we can put, or the actions we can able to put. So this is your static threshold. Anomaly detection means, like, anomaly means what? Have you seen this in the movies? Someone is in the hospital. Okay, if you see in the movies, someone if in the admitted in the hospital, at the left side of them there will be a small TV. What is that one? ECG. Have you seen that?
Yes.
ECG monitor. Yes. What it will show actually? How it will show?
Sort of a graph type.
Yes, exactly. So this graph, this is the graph of this CloudWatch. Now, what it will do? We might have mentioned a condition. We might have mentioned a condition here, like 70%. It reach 1 minute. Also, you have to launch one more server. Now, you are asking, na, what will be there in the CloudWatch? You asked me. I mean, sorry, no, you asked me that what will be there in the solution architect. Correct,
Mm.
na? Now, this is a best example. Now, this anomaly detection, what is metric math and all, in depth there will be there. Okay, in depth in sense how it will work. What are now again 2 to 3 more slides regarding this.
Mhm.
Okay, now anomaly detection is, see, we previously in the static threshold we mentioned a condition that average 5 minutes, but in the anomaly what is happening, once you reach that 70%, 1 second also it will launch one more server. Now which one is better? Which one is better? Launching a server immediately within a second once it reaches that 70%, or wait and see whether 5 minutes, let us wait and see whether it is the same workload is continuing or not.
First one.
Wait and
Yes, exactly. So that's what the difference is. They will give you options. We will be checking which one save money, as well as which one is we are comfortable with. Next, metric math is again similar to this one. Metric math, as a name itself says, math. That is, when the CPU or when the size of this is equal to this value, like 10, then I want this to be increases server. No, if no, some two or three functions has to work together, that output should match the condition. If that is, for example, the condition, then we can able to launch. Like that, we'll have a metric math. Maximum will be using only static threshold.
So, in which situation that
Hmm.
5 minutes the option will be, or in which situation wherein they will delay the process? Like, because mostly we will look for a immediate solution,
No,
which
but the thing is, we see immediately the condition is what? Here, what is the condition? Let me take the CPU, okay?
hmm,
If the CPU is two CPUs are there, if both together more than 60% workload for 5 minutes, why we want to have 5 minutes means, see, for example, the customers might be coming when waiting for 2 minutes only in the server, correct? Not 2 minutes, not
hmm,
even 2 minutes. If the page is not loading for 1 minute, what you will do?
raise a ticket.
Yes, exactly. Correct, na? So there is not an event that he will keep on waiting. There might be a situation where the CPU was working in some other work. That's why it is taking both of the people are working. Now it has finished one task. Immediately this will come down. 60% might come down to 59%. Now,
Hmm.
as per the record, it is not meeting the condition. Na?
Yes.
Now at the time, why should I want to launch one more server and cost it additional cost?
Okay.
Why we want to take additional? So wait for 5 minutes and see whether the workload continues. See, just because Diwali is the peak season, I took an employee for my cloth center as a part-time employee. Previously, it was only two employee. When Diwali time comes, we add one more employee as part-time. Now Diwali over. On 1 or 2 days, there will be a Sunday or Saturday. It will be very peak season, very more number of customers. For that 2 days alone, will you take this guy, or will you ask these two people to manage it? Other days they are remaining sitting simply, or let us say they are no, they don't have that much crowd. What you will do?
Manage
You
it.
will ask, yes, you will ask these two people to manage. Now only Saturday Sunday you guys manage. Weekdays there is no crowd, there is no work also, less work only. So you manage. Same criteria only. 5 minutes. Let us wait and see whether this workload is continuing till 60%. It is managing. Then after 5 minutes, automatically one more server will get added. Instead of going for anomaly detection, that immediately you have to launch one more server, no, it's again cost is high, because after 2 minutes, if again the workload is less, then whatever money we have spent is lost, right? And this alarms, CloudWatch alarms will always take static value, that is round values, that is round values only it will take. It will not take any approximate value. It will not take any approximate value. Now here you can see this CloudWatch can be configured to all these services as well. All the services as well. So here you can able to see CloudWatch is associated with EC2, that is server. If they want to check whether these conditions can be able to manage by CloudWatch or not. If CloudWatch is able to manage, then we have to say correct, and if not, it is incorrect. Now let us take the first situation. If average CPU utilization is greater than 60% for 5 minutes, is all these condition is correct? Just now I told you the same condition. Is all the metrics and everything is clear here?
No,
Yes, sir. Yes. Yes, it is 60% and
yeah,
above if you
60%.
go
Correct.
for 5 minutes.
For
So it is
5.
correct. If the average CPU utilization is more than 60% for 5 minutes, you increase or sub decrease or whatever it is. But the thing is, CloudWatch condition, we are giving a condition, is that condition is correct or not? That's what we are checking. Next one. If the number of simultaneous connections greater than 10 for 1 minute, greater than 10 for 1 minute, yes, it can able we can able to see that the simultaneous connections is going greater than 10 for 1 minute. We are giving a condition. We have one specific values. So this is also correct. Now in the S3 bucket, we are saying if the maximum bucket size in byte is around 3 for 1 day. Now is there any specific value here? Like the previous metrics. Here we mentioned 1. Here we mentioned 10. Okay, above 10 means I will start this condition. Above 60 means I will take a condition. Now here they mentioned around 3. Now
Hmm.
what decision we can able to take? So it is incorrect. We cannot able to take a decision.
Yes.
Next one, load balancing. If the load balances, if the number of healthy hosts is less than 5 for 10 minutes, you add one server. Now I said the condition is correct. Yes.
No.
Why it is clear now? We have specific value 5. Below 5 it will go means it will automatically add one more server. That to 10 minutes it has to wait. First condition, second condition. I mean the values are specified, no?
Okay.
Correct. Now if the volume of read operation is 1000 and above for 10 second, 1000 and above for 10 second. Now what they are mentioning elastic block store. We are mentioning volume of read operations. So volume of read operations means we have to give some aggregate values. We have to give some aggregate values because two servers are running. Minimum always two servers will running. So aggregate means what? We have to have some conditions like average, some count like that we need more than 1000. It's not like one server we read operation only. There can be multiple operations. So read operation we need some average or count. So this is incorrect. Let us see what is happening. What is the answer for all these things? Now you can able to see that as I told you, this is correct. Specifically, they mentioned 60 and 5. Here it is 10 and 1 they mentioned. Here it is round 3. So we cannot have any round values. Either you should have mentioned any threshold values like greater than or equal to, less than or equal to, something you have to mention so that it can able to take one value. Okay, above 3, yeah. Okay, I will take from above 3. Above less than 3, something. Now same here, less than 5, 10 we have written. Here we have to mention a static value, for example like average volume of. That's why it is incorrect. And this and all, when you use it you will come to know. Anyway, you just understand the conditions, how to give a work from in CloudWatch conditions. Come to the end of this section. Amazon CloudWatch helps you to monitor your AWS resources and the applications that you run on AWS in real time. So CloudWatch enable you to collect and track standard and custom metrics. It send alarms to automatically send notification to SNS topics or perform Amazon EC2 Autoscaling or Amazon EC2 actions. Define rules that match changes in your AWS environment and route these events to targets for processing. Right. Coming to the third section, name itself says what we are going to see. We are going to see EC2 Autoscaling. How automatically EC2 is going to get autoscaling by itself. Now, why we need scaling? Let us say Sunday This is 10, we can say. This is 8. This is 7, 6, 5. Now this is 3. This is 2. Now we are able to see why scaling is important. Why scaling is important. So here you can see we think that on Wednesday there are huge crowd. Let us say Wednesday there are huge crowd. So we bought 10 servers to manage. Now what happened? They bought 10 servers, but the remaining days what is happening? Only 2 servers is utilized, only 6 servers, only 7 servers, and Thursday it is only 8 servers, and again Friday it's 5 servers, and Saturday it is 3 servers. Now what we lost here? We took already paid for all the 10 servers. Are we utilizing this all the 10 servers every day? What we lost here? Are you guys you're able to getting this? Okay, best example would be like, let us say you were having these, you might have attended the marriage functions, or you might have faced the same issue in your marriage function. You might expected 300 crowd, 300 crowd, but only 200 came. How many food order you'll made for 300 crowd? You approximately
Say 350 times.
300. You will order 350.
Hmm.
Okay, now 50 extra. But what happened?
Yes.
200 came. What you lost here?
No, we lost money to the extent of that 150 plates.
Yes, exactly. What you lost? Money.
Money.
Correct. Now here, the same situation. We bought only 8 servers, but on 10th, that is on Wednesday, there are more cloud, but your site is not reachable.
Hmm.
The other days it is reachable. Correct na? 6, 7, 8, 5, 3. But Wednesday alone, what you lost? You lost anything?
Lost my customers.
Exactly. Now both are bad scenario. Here you lost money. Here you lost customer. Correct na? Now same thing. This food also same thing. Like you, if you expect, uh, you bought 300, but 400 came. Correct na? That is also customer lost. Like your, I mean your relations might feel bad. Correct na? So same thing. Now
Yes.
this is a bad situation. Here we lost money. Here we lost customer. Now this situation should not happen. What is the solution? That is called auto scaling. Now we bought server, 2 server. What AWS will do? AWS auto scaling mode you are on, so it will keep one server buffer. That is, 2 is minimum running, third one is being ready, getting ready. It is ready, but you have not used it, but it is already ready. Now same thing here. It is 5. 5 server means 6 servers ready. Here it is 6 means 7 server ready. Here it is 7 means 8 server will be there. Here it is 5 means 6 server will be there. Here it is 3 means 4 servers will be there. Here it is 10 means 11 servers will be there. That is one in buffer, it will keep on having it. So it will enables you to add automatically or remove EC2 instance according to the conditions that we define. One. Second, it will not charge you for the 11 servers here, you see, until and unless you use it. It will be ready, but until and unless you use it, it will not be charged. And also, the main advantage is it will keep on checking your servers. It will keep on checking your servers. If there any EC2 instance, that is any of your instance is unhealthy, then it replaces that instance. that instance without your intervention. It will not ask you. It will keep on changing it by itself. We don't want to do anything. So whenever the load comes, so the load increases, it will add and keep the buffer ready. When the load is gone, it will reduce. It will reduce by itself. That's what it will add or remove EC2 instance according to the conditions that we define. Conditions means we'll come to the next slide. We'll understand how to put the condition. It provides several scaling options. What are scaling options? We have manual scaling, scheduled scaling, dynamic scaling, and predictive. So what are these types? Let us see. So you understood this one, auto scaling.
Yes.
Yes. Now here you see what is the typical weekly traffic of Amazon. Weekly traffic is Sunday, Monday, Tuesday, Wednesday, Thursday, just like this. Based on provision capacity, they have won these many servers, and it was okay. Now what they thought, suddenly on a specific day, that is like Thanksgiving day, they thought more people will come in that month of November, and they bought these many servers. These many servers. Now what has happened in that month? You're able to see Monday, first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th. Only one day it has reached somewhat. Again goes down. Again one day it has reached. You see, 76% of the server is wasted. That is, you are paying unnecessarily. You bought it, and we used only 24%. We used only 24% utilized. So provision capacity and used capacity. Now, how auto scaling will work? So this is a auto scaling will work. So we first one, first server, second server. Auto scaling is nothing but it's a collection of EC2 instance that are treated as a logical grouping for the purpose of automatic scaling and management. For the purpose of automatic scaling and management. So automatically add and automatically release. First we have to, when you put auto scaling, first we have to mention the desired size and minimum size and maximum size. First you said desired means always, as I told you, always two servers are running. Always two servers are running. That is desired. In case very rare situation, you go for minimum size. Minimum is one server at least you have to run. Next, what is the maximum size? This is the condition which we have mentioned. Condition means this is the condition. In the previous slide, I told it. Based on the condition, it will increase. Now, here is the condition we are giving. You can go up to maximum this size, that is 4 sizes. You can go with. So that's what we are giving a condition. Now, let us take this service. The server is T2 micro. T2 micro. Okay. This is T2 micro, and this is also T2 micro. These two are not added because the workload is not there. Now workload comes, more workload comes. Now can we add, instead of this T2 micro, can we add T2 medium, which will be more faster, or T2 nano, which is somewhat lower? Can we add this third server here with another configuration like T2 micro we started with? Can we add a T2 medium, which is higher configuration, so that the workload can be balanced? Workload can be finished faster. Can we do like that? Is it okay?
Yeah.
Yes, sir.
Yes.
Okay. Let me explain you. Let us take this car. Now this car is running with two wheels. Okay. Now the third wheel, that means let us say this car tire got punctured. Okay.
Mm-hmm.
Now can I put a tractor tire here?
No,
No. Correct. Can I put a scooty tire here?
no.
What I have to put?
Same car tire.
Yes, exactly. So that one, then only what will happen?
Balancing.
They'll have a proper balance, correct? Na? Same thing here. We started with T2 micro, so we have to continue with T2 micro only the next configuration also, the attachments, the additional configurations. We cannot go for any larger or smaller one also. Okay. So now T2 micro we started means we go with T2 micro only. Whenever we want, we can keep on adding. It's nothing but like your let us say fifth standard students is having a quiz, and sixth standard students is also, we are conducting a quiz between fifth and sixth standard students. Can I put one person from sixth to here and fifth to here? Will they accommodate other persons?
Mm.
Correct. Same thing.
Right.
Yes, same thing. So auto scaling, when we start with T2 micro, it has to go to T2 micro. Whatever server you are taking, the same server you have to continue. Now, what we are doing, whenever the load balancer, that is auto scaling, first you have to register in the load balancer will send the traffic, right? Now scale out is called your adding a server. Scale out is called adding a new server. Scale in is called terminating. Scale in means called terminating in the instance. That is, if you want to add a server, we call it a scale out. If you want to remove the server, then it's called scale in. Fine. So you make a note of this one: scale out and scale in. Scale out means uh, adding server. Scale in means terminating server. Now, how this auto scaling works? So, as I told you, say T2 micro we might have started with. How this T2 micro alone again come and join. So, first we have to have the AMI. In the AMI, we have EC2 instance. In the EC2 instance, we might have launched. This is my AMI. This is my instant type. That is T2 micro only you have to launch. And we assign that IAM role, security group, and EBS volume, everything we set to that new server added. So now this new server will be added to the auto scaling group. Only thing is we have to mention which VPC, which subnet I have to go, which load balancer I have to register. That we have to mention. Now automatically that server will get added to the auto scaling group. Now as we already mentioned, auto scaling will work on several types. So first one, maintain the current numbers. It will keep on checking the health condition of your servers. It will keep on checking. Maintain the current number. If something happen or unhealthy, it will immediately join. It will immediately add one more server. Next one, manual scaling. We go manually and mention minimum, maximum desired capacity, or we go and add a new server. That is called your manual scaling. Schedule scaling means, as we already mentioned, I think long back we have talked, like January, February, March, April, May, June, July, and October, November, December. Now, this October, November, December alone, I want, instead of two servers, I want four servers, as this is a peak season. Now, I'll schedule it in this month of January itself. Scheduling the scaling, automatically it will get scaled. Next, dynamic scaling. Dynamically, it's based on the workload. Based on the workload, or we go and change manually also. Dynamically, we can able to change the scaling policies. We can able to change it. Dynamic means you want frequently changing. See, 1 month it will be there. Like 1 month, I need only four servers. Next month, I need only six servers. I can need only two servers also enough. So those things we can able to change dynamically based change on the website and the workload. We can able to change it. And this last one is predictive auto scaling. That is, we don't want to do anything like how your weather is forecasted. How your weather is forecasted? How our weather is forecasted?
Based on the predictions.
Is based on which day's prediction? Previous date predictions, correct now?
Yes, yes.
yesterday it rain or day before yesterday it rain, and definitely then it is obviously that today it will rain. Same thing, we go with predictive auto scaling, and then it will automatically predict and it will scale by itself. We don't want to do that. So whichever type we want, we can able to select that. Now here is what how the auto scaling works and how all these connections work. So here you see we give a condition in the CloudWatch. That is, if average CPU utilization is more than 60% for 5 minutes, then you add one more server. So first, CloudWatch alarm will send a notification to us through SNS because we are the owner. Simultaneously, it will inform the auto scaling to add one more server here to the auto scaling group. Now this auto scaling group first will check, will do the health checkup. Which one? Auto scaling group also will do the health checkup whether the server is in a good health condition or not. Then again it will register in the load balancer. Load balancer will become the target. Now load balancer as is the manager, like your manager, and you are the new employee. Will the manager will give the new employee the task immediately once he joins?
No.
No, he has to check now whether what he is doing, what he is performing, whether I can give the task to him, whether I can give the project to him or not, right? Same thing, elastic load balancer, again it will go and check whether this server, new server which is attached, is it in a good condition or not. It will again check. Then yes, it is in a good condition, it can able to receive data means, then it will do the traffic, it will send the traffic. That too, what is the condition? We mentioned 60% 5 minutes. Now, again after 10 minutes, if this percentage goes down like 50 percentage and it become 5 minutes. So now as per the condition, it has to reduce the server. Now automatically when it becomes 50 for 5 minutes, it will go and remove the server. That means auto scaling will get remove this server automatically and come back. So this is what auto scaling automatically scale the servers by itself. Now this auto scaling is not only in EC2 option, we have in the container service also, in we have this auto scaling in the DynamoDB tables also, and Aurora replicas also. So mainly it monitors your application and automatically adjusts capacity to maintain steady, predictable performance at the low possible cost. Mainly we need auto scaling because I have to reduce the cost. I don't want to spend 10 servers always. I have to reduce the servers, so I put auto scaling. It will automatically add the server and delete the server whenever it is not necessary. So this auto scaling is not only there in the EC2, we have options in the ECS as well as DynamoDB and the Aurora also. We have this auto scaling option, but it's not related to servers. Elastic computes ECS, it is related to server. DynamoDB, it is regarding the table and indexes, and Aurora replicas. It's mainly for the replicas. Coming to the end of this section, the scaling enables you to respond quickly to changes in the resources needed. And EC2 auto scaling maintains applications availability by automatically adding or removing EC2 instances. An auto scaling group is a collection of EC2 instances. A launch configuration is an instance configuration template. And dynamic scaling uses auto scaling, CloudWatch, and Elastic Load Balancer. And AWS auto scaling is a separate service from EC2 auto scaling. So there are, as I told, two service. EC2 auto scaling is different. General auto scaling is there. General auto scaling is applied for these three. And the other services, what we have to know, these are other services extra only. I'll just give you some information about these things, and then we'll come to the end of this course, I mean, end of this module. Okay. So what is this cloud formation? Cloud formation is nothing but a stack. What is meant by a stack? Stack means what? We are saying full stack. Anna, what is meant by a stack?
Bundle of uh, tech
Same
stack.
items.
Yeah.
Okay, tech stack. Okay. The same thing only. This cloud formation provides a simple way to mainly to model, create, and manage collection of AWS resources. It was as a full stack you have mentioned, like same thing, like full stack is tech stack. Here it is all AWS resources, all AWS resources one after the other. So now this collection of resources is called as AWS Cloud Formation Stack, and no extra charge. It is a free service only. Pay only for the resources that we create. It will help you to create, update, and delete the stacks as well. So enables you orderly, predictable provisioning and updating of all the resources at one shot. Mainly, it helps you for version control. What is a version control tool? Which one is a version control tool? Mainly, the CIs. I mean, the GitHub is a version control tool. Now this what will do, why we want this cloud formation means, for example, here you see first we set a template like all the stacks. Like here you see Route 53, load balancer, sorry, auto scaling, load balancer, and EC2 instance. Now all these are bundled, right? Route 53, auto scaling, elastic load balancer, and EC2. Now one after the other is there on top for two. Now for this how to do, it's already created a template like a task build in an Excel, in a notepad we create and keep it. Which one has to do first, what action first have to do, second action, third, fourth. Like that we'll keep it as a template. That template will upload that template to the cloud formation or point to a template which is already stored. If that template is already stored in the S3 bucket, you can direct that to the S3 bucket template, or you just upload the file. Now what it will do, it will run and create the stack action resources created on the cross a multiple service. That is, it will run one after the other. Then in case if that stack is not necessary, you think no, it is not working fine, it is not giving the output what I am looking for means, then you can again update the stack or delete drift and delete the stack. Drift means nothing but if someone goes and edit your template, your cloud formation template, that it will show an error. That is called drift deduction. So it will be that those things and all will be learning in depth. Now this is just a cloud formation, just to know what is meant by a cloud formation. It is nothing but a tech stack. Here it is AWS stack, where you can able to deploy multiple resources in one shot. For that, just we have to write the template. Next, AWS Quick Start. As I told you, like 200 plus services we have. One of these services is Quick Start, where the name itself says we call this as Quick Start or a golden standard deployment. Golden standard deployment. Why means it can be used to create the entire architecture with one click. Entire architecture with one click. Nowadays, will you want to design a website? Will you go and start with HTML again? You want to design a website. Will you go and start a website newly? I mean, you'll go and type the HTML, CSS, and all. You'll start and type.
No.
What you'll do? You go for free templates.
Yeah.
Exactly. Now same thing only. We don't want to do configuration and all those things. It can be created the entire architecture. You can able to use this as a best practice, where it can be used for experiment and as the basis for your own architecture. You can go and take this quick start, automatically all the deploy configuration is there. If we want to do some customizations, we can do and put some best practice for security and availability. So these quick starts are built by our solution architects already and partner to help you deploy your popular solutions on AWS based on AWS best practices for security and high availability. It's fully configured and secured. We can just go and take and use it. Only thing is customization we have to do. This is one of the service. Another service, important service is system manager. It is nothing like but your task manager. In the task manager, will you able to see all the applications that you use, how much traffic, how much incoming resources, memory, how much it is taking, right? In the task manager. Same thing here. This systems manager will give you operational insights and take actions on the AWS resources. That means it will automate the operation tasks such as applying OS patches, Patches means again updates, upgrade, software upgrade across fleet of EC2. Fleet means what? Multiple group of fleet of multiple or group of EC2 instance. It helps you to manage your software inventory, view detailed system configuration across the fleet, all the instances, and manage servers on premises and in the cloud. Both it can able to manage. That's called your systems manager. It is nothing like but your task manager, or it will know what is happening in your system, what insight you can get, what resources are running extra, what resources are need update, and everything it will know. This is your systems manager. This is also one of the service. Not means it is be inside the AWS Amazon console. Now this systems manager will have the capability to control the entire AWS console, how it is doing, how it is getting updated of everything, just because it is having an SSM agent, that is systems manager agent. It will be there in the EC2 instance. Now that will be sending the update monitored information to the systems manager, and it will get updated, manage and configure it. So we have all the options in the systems manager, like run command, patch manager, session manager, maintenance window, inventory, parameter store, automation, documents, everything control, everything will be there in the systems manager. We can able to go and change it whenever we want. Next one, API gateway. So this API gateway is mainly for help you to create, publish, and maintain, monitor, and secure your all your API requests. That is, whatever resource, whatever user is trying to interact and everything, whatever you're communicating from one resource to another resource, that is also coming under API. So API can be handled with hundreds and thousands of concurrent APIs. That is, as you see, is Instagram is used by only one person or multiple people? Multiple people, right? So every click is an API. Every click is an API, correct? So it handles up to hundreds of thousands of concurrent APIs. It will mainly handle all the workloads that run on your top of your EC2 instance or Lambda or any web application or real-time communication as well. So this is like just an entry point. How we have this. I think we learned Route 53 na. Similar to that, the API gateway. As why we are calling this as API gateway? Why they always keep the name as gateway, gateway, gateway? Why they are keeping as a gateway?
because
So
it
there is a kind of a
allows
security is available
Check.
something
Yes,
sensitive is
exactly.
not.
Security
check.
check.
Yes.
Yes. So that's why I'm mentioning whatever it is, whether your workload is on EC2 or Lambda or anything, when you come to API, it will give a check and then it will allow in and it will handle the request faster. That's what it's saying. It can host and use multiple versions of stages for your API. So here you can able to see common architecture. For example, you're using a website, mobile application or a website or an AWS one or on premise. First you come to internet. Internet will go to CloudFront. CloudFront will send it to API gateway. And CloudWatch is already connected to the API. It will keep on monitoring. And the API cache memory. That means the same request is coming again and again means it will go to the API gateway cache memory. API is approved and it will resource, okay, what action you want to take, whether in Lambda or EC2 or VPC or any other service, or you have to go out of the public internet. So everything will be coming across API gateway only. So it will have one more security check before it's allowed to before the user is allowed to access other resources. Next, SQS. SQS is nothing but simple queue service. This is nothing but like your mobile message service. Mobile message, normal message, not WhatsApp message, normal message. Now, when you switch off your phone, what will happen? Somebody is sending a message to you. What will happen?
It will be received once when we switch on it. It will be there in the
Okay. But in case you might have noticed that sometimes when you switch off your mobile and on, no messages might come. Maybe the messages might come very, very late.
Yeah.
Correct, na? That is this one, SQS. That is
Cues.
queue service. That is the consumer will be sending the message. That is the consumer will be sending the message. Consumer in sense the producer will be sending the message. He's the producer, message producer, and it should be delivered to the consumer. But it will go to a buffer. But it will go to a buffer queue. It will go to a buffer queue. The message will go and sit in the queue. The consumer has to pull. The consumer has to pull, or we have a use the pull mechanism. Here the SQS will follow pull mechanism where once it reads, then it will get deleted. So that's what fully managed message queuing service. It is follow pull mechanism where messages are encrypted and stored until they are processed and deleted. Until they are processed and deleted, there it will be there in the queue. Producer will send the message. Consumer is there. To consumer, it has to process. It has to pull mechanism. That is, it will pull the messages whatever we have and send it to the consumer. It acts like a buffer between the producer and the consumer. That's your SQS. So SQS will follow standard queues. Two methods. One is standard queue. That is at least one time. At least one time you deliver. That's what you see. Just know it all. When you switch off your mobile and switch on, the message will come very late. So what is the condition is at least one time you deliver it. You don't mind about the time. That's why you see 1, 2, 5, 3, 3 again it came 4. You might have seen that Airtel or some other messages will keep on coming again and again. Two times the same message. Correct na? So it will take for a best ordering and nearly unlimited throughput. Unlimited throughput means speed, bandwidth you can able to say. Another method is first in first out, as we already know that what is meant by first in first out. Which message has been sent first, only that will be processed first. Second is second, third everything. What is the condition here? Exactly once only you have to process, not two times. That is the process here, condition here. That is a method. Here also it is high throughput. These are the types in queue service. Next is SNS, yeah, this simple notification service, that is mail service. Now this will follow push mechanism. SQS will follow pull mechanism. Here it is push mechanism, where it is a highly available, durable, secure, fully managed pub and sub. Pub and sub means publish and subscribe. Where you have publisher and subscriber, where you have publisher and subscriber in your daily life, you have subscribers. Now where it is, where you see this word mainly.
Amazon Prime.
Okay, you have YouTube
Yeah. Subscribe also.
subscribers. Yes, exactly. Now it suppose encrypted topics using custom master key. That means let us see here. You can see the publisher, the YouTuber. Once you subscribe to his channel, he will post some data into his upload his some video into his account. Automatically, that topic is messaged to all the subscribers. So here it is push mechanism. That is when you publish it, automatically it is pushed to all the subscribers, whether he is liking or not. Whether he is liking or not, it will be mailed. It will be mailed. I think you might have get some campaign mails and all automatically they will send you when you subscribe for somebody in YouTube or Instagram or whatever wherever you subscribe, they will automatically send you mails. That means they are pushing the mails to you without your consent. But you have, since you already subscribed, you are a subscriber, so since you are already giving an confirmation that you can send me mails, they are pushing the data. This is push mechanism. So this publisher, he'll put the topic. It can be an email or it can be a website. It can be a short message. It can be a mail or a queue service. It can able to forward to a Lambda also. So the support protocol, SNS will support all. SNS will support all. It can be an email. It can be HTTP request, short message or SQS queue also it will go. And Lambda function also to trigger also it will help. That's what we are getting mails automatically triggered. So this is the difference between these two. Here it is SNS and SQS. So SNS is publisher and subscriber, SQS is producer and consumer. Here it is publish and subscribe, send and receive. Here it is push mechanism, here it is pull mechanism. Here the module is many to many because everyone are getting mail. Here it is one to one because your WhatsApp message, not WhatsApp, your normal mailbox message, that is one to one. Here it is everybody are checking, all those subscribers are getting mails. Message persistency, here it is no, they will not record anything. It's a mail. Here it is recorded because it is only sent for you. So this is a difference between SNS and SQS. So coming to the end of this section, we learned about distributed traffic across multiple elastic compute cloud, CloudWatch, and as well as EC2 autoscaling and load balancing. We discussed. So here we can able to see the 25 cloud terms very big, every beginner should know about. So vertical scaling, visualization, multi-cloud Docker. I just added this new slide. It is not fully. I'll send you one more file. Okay, what are the 50 services that we should know? This is general terminologies that you will be able to see. What is mean by hybrid cloud? What is container? What is this one? All the basic definitions are there. Coming to the knowledge check. Which service would you use to send alerts based on Amazon CloudWatch alarms? I told you it will be sent you as a mail. Do you remember that? Which one is the mail service? When you reach that alarm condition, which service would you use to send alerts based on Amazon CloudWatch?
Amazon full
When you have
notification service.
Amazon?
Simple notification service.
Yes, exactly. Simple notification service. You also set the budget, na? Budget mail notification. When you cross the budget, it will automatically mailing you, na? All right. Okay. We'll see the answer. Send alerts. It's answer A. That is Amazon simple notification service. Fine. So we have completed all the theory and the 10 modules as well. Now tomorrow 3 days we'll do practicals. So what labs we have left out? I think one Lambda lab alone we have left out. And again we'll launch a server. Okay, we'll launch a server. As I will show you. See, mainly you will be launching a website. Correct? Now you'll be launching a website using mainly through AWS. Now there are 4 methods for launching your server. One is S3 bucket, which we have already done and launched it. Another one is EC2 instance that we launch it. And another one is this load balancer where we can able to have the load balancer and we can able to deploy it. That is how we can give the public access to load balancer. Next one is your cloud front. Okay. So now all these things we'll see so that it will be helpful for you for learning the other labs as well. Okay. So yes. Do you have any questions?
No.
Okay, fine. So we'll see you tomorrow at the same time and we'll start the lab. Please come with your laptop and simultaneously you can do it. Okay. Yeah.
Yes.
Okay. Yes. Yeah. Thank you.
Right.
Have a good night.